The biggest risk in the agent era is not that an agent makes a bad decision. It is that nobody can prove what the agent did or undo it later. Right now, most agent systems work, but they work like one-off integrations. You stitch together bespoke APIs, adapter code, and vendor-specific logs. It looks fine inside one platform. The moment work crosses tools, clouds, or organizations, you lose shared meaning. You lose clear authority boundaries. You lose replayable state. And you lose audit trails that survive a dispute. Open agent protocols aim to fix that. Think of them as standardized, vendor-neutral interfaces for delegated machine work. An agent should be able to prove who it is. It should ask for bounded authority. It should invoke tools with known schemas. It should hand off state cleanly to another agent. And it should leave behind an execution record that can be audited, replayed, or challenged. A useful way to see the problem is to look at where interoperability actually bottlenecks. Identity binding is first. If an agent takes an action, you need to bind that action to a durable identity. Not just a runtime token, but a revocable identity with accountable ownership. Without that, every incident turns into finger pointing. Next comes scoped authorization and the semantics of delegation. Permission is not a single bit. It has scope, duration, constraints, and escalation rules. An agent needs authority that is narrow, time-bounded, and explicitly described. Otherwise, delegated work becomes delegated risk, and privilege creep becomes normal. Context packaging is another choke point. Agents rely on state, memory, and prior messages. When that context crosses a boundary, it becomes a new attack surface. It also becomes a source of silent failure. If context is incomplete or subtly altered, downstream actions can drift. If it is too complete, you leak sensitive information. So the portable unit of handoff context has to be minimal, structured, and defensible. Then there is tool schema normalization. Many platforms can call tools, but they don't agree on what tool descriptions mean. Two vendors can both label a field amount and mean different units, rounding, or side effects. In practice, that semantic mismatch is where automation breaks. Over time, it becomes the reason organizations stay locked into one stack. Finally, there is trace, audit, and rollback. A serious agent system cannot just return an answer. It must return a record of what it tried, what it touched, what it produced, and what it committed. And when things go wrong, you need revocation and, where feasible, rollback across organizational boundaries. If that sounds like bureaucracy, remember the lesson from scientific workflows. The most durable machine ecosystems did not win by being magical. They won by being boringly stable. NumPy became foundational because its core semantics stayed consistent, and extension patterns let an ecosystem grow around it. Kime2 became a reproducible workflow platform because it treated provenance as a first-class output, not an afterthought. Those communities show what interoperable machine work looks like when it is built for reuse, not just for demos. Provenance matters for a simple reason. In high-stakes environments, the question is rarely, did it work once? The question is, can we reproduce it, explain it, and defend it? Systematic reporting norms in science pushed that discipline for humans. Delegated autonomy will need the machine equivalent, because agents act faster, touch more systems, and create more complex chains of cause and effect. So what does a minimum interoperable record look like when an agent does real work? Start with a principal identity, the responsible organization or account. Add a stable agent identity that supports rotation and revocation. Capture a session identity, a bounded container for what happened. Then record the delegation scope in machine-readable form, including resources, tools, data domains, spend limits, and time windows. You also need a snapshot of the tool registry, hashed or versioned. That prevents tool drift disputes where the tool changed after the fact. Every tool call should be normalized, with tool name, tool version, schema version, and hashes of inputs. For replay, capture environment attestation like a container or dependency lock so you can reconstruct the runtime. Then store an ordered execution trace, including authorize, invoke, result, verify, and commit or rollback. Finally, link output artifacts back to that trace and connect multi-step work into a provenance chain. Once you think in those terms, the message flows become clearer. An agent asserts identity. It discovers available tools and constraints. It requests delegation with explicit bounds. A system grants or denies that delegation with expiry and audit requirements. The agent invokes a tool. The tool returns results with verifiable artifacts. The agent attests to execution with a signed summary and environment details. Then effects are committed or rolled back. Context can be handed off to another agent, but only with bounded permissions, and revocation must always be possible with a defined effective time. That last point, revocation, is where strategy meets engineering. If you cannot revoke an agent's authority quickly, you don't have delegated autonomy. You have uncontrolled automation. Targets like revocation within 60 seconds are not a nice to have. They are the difference between a contained incident and a cascading one. Adversaries will aim at the seams. Context injection is a predictable attack, especially during handoffs. A poisoned context can smuggle instructions, false assumptions, or malicious data. Tool poisoning is another, where a registry or schema is substituted, and the agent calls the wrong thing with confidence. Overbroad delegation scopes invite privilege escalation because agents optimize for task completion unless you constrain them. Replay attacks can reuse earlier tool invocations unless you require nonces and monotonic counters. Silent state corruption happens when partial updates or dropped events create an inconsistent story, and nobody notices until damage is done. The uncomfortable truth is that most failures will look like normal operations. They will not crash loudly. They will succeed incorrectly and leave just enough ambiguity that accountability becomes expensive. That is why procurement language becomes a technical control. Buyers can force interoperability by requiring exportable state, revocation guarantees, schema versioning, and third-party replayable traces. Exportability is not we can download logs. It is given a session identifier, we can export the full state and audit package and replay most workflows independently. In mature environments, you should be able to sample production runs and replay them outside the original vendor stack at high success rates. Schema stability is another leverage point. Every tool call should carry a schema version. Backward compatibility should be measured across multiple prior major versions, not promised vaguely. Trust zones also matter. Separate read-only analysis agents from effectful action agents. Make it impossible for a low-trust agent to cross into high-impact tools without explicit approval. You can see how this plays out in real operations. In a multi-SaaS support workflow, the win is not that the agent writes nicer messages. The win is that every customer-facing action carries a trace hash, a delegation scope, and a tool registry snapshot. When a dispute happens, you can replay the chain. You can answer who changed what, quickly, across systems. Now picture the opposite. A closed-stack agent platform changes a proprietary tool schema. Downstream actions silently corrupt. The logs are vendor-specific and cannot be replayed outside that platform. Incident response becomes negotiation. The fix is not another prompt. The fix is a contract requirement for exportable traces, version schemas, and conformance tests. Over the next decade, expect a familiar pattern. First comes experimental interoperability, mostly adapters and brittle handoffs. Then partial standardization, where common interchange formats and third-party audit tools become real markets. After that, these protocols harden into infrastructure, like identity federation and APIs did before them. The lock-in consequences will last far longer than the first products. Treat open agent protocols like critical infrastructure, because that is what they become the moment agents can spend money, move resources, or change systems. The long-run advantage goes to the organizations that can delegate machine work and still prove, revoke, and replay it later.